Hi everyone, in this video we'll look at 2019 paper 2 GCE question 1b. Question 1 says, in a geometric progression, the third term is 16 and the fifth term is 4. Calculate 1, the first term and the common ratio, 2, the 10th term, 3, the sum to infinity. So for us to solve this question, if you look at here, they are saying that there is the third, okay? So you have the third term, for example, you have the third, then, and you have the fourth. You see the third and the fifth, term number 5. You have term number 5 again. You see that? So this one is term number 3, this one term number 5. So if you can see here, for you to move from term number 3 to term number 5, in between here there is term number 4. So which means we cannot find the common ratio direct or the first term. So in this case, if there is a gap like this, you have to use simultaneous equation for you to find the first term and the common ratio. So how do you do that? So you have to say term number 3, third term, as given here. The third term is 16. You say the third term is 16 and the fifth term or term number 5, the fifth term is 4. You come up with details like this. Thereafter, since it is a geometric progression, we are going to do as if we want to find term number 16. So you say that your n, we'll do as if we want to find term number 3, not term number 16, since the third term is 16. So term number 3 or the third term, it will be presented by n. n will be 3. Okay, even this side, n will be a 5. So we will do the same. Now let's use this formula. We know that Tn is equals to A, then n minus 1. So where there is n here, you can see we will put what? A 3. So we said T3 equals A. So our A we don't know. Then a common ratio we don't know as well. Then n we know is 3. So we say 3 take away a 1. But here on the third term we know, since third term here, you see that third term is equals to 16. So we will replace 16, then equals to A, open the bracket, close it, then we say 3 take away 1. This 3 take away 1, it is 2. You see that? Then we say 16 equals A r. This r to the power 2 or 2 to the power r, right, to just give you r squared. This will be called the first equation. This will be called first equation. So we'll leave it here first. Then let's go to term number 5. This term number 5, we use the same formula. We said Tn equals to A power n minus 1. Then where there is n, we put term number 5, which is here T5. So we say T then 5 equals to A r. We open the bracket rather. Then we say n. So n is a 5. So 5 we take away 1. Then we replace T5. We can see term number 5 is 4. So we say 4 equals to A. Then open the bracket, we close. 5 we take away 1. We'll get a 4. Then we say 4 equals to A. Then r to the power 4 is r power 4. this will be called equation number 2. So we have two equations, equation 1 and equation number 2. This is where we are now. Okay. So from this point, we are going to make A the subject of the formula in equation 1. Okay? In equation 1. In equation 1. Okay, I'll put 1 there. So we'll have this. So we say make A the subject of the formula in equation 1. Equation 1. So equation 1, it is this one. You see that? This is equation 1. So we want to make this A the subject. Okay. So we have 16 equals to A R power 2. So to make A the subject, you say over R squared over R squared. You see that? So you cancel this so that this A remains alone. So A will be equals to 16 over R power 2. This is called equation 3. This will be called equation 3. Since we have equation 1, equation 2, then equation 3. So we are saying make A the subject in equation 1. So A now, it is the subject. So the next thing that we are going to do now is that this A that we have make it the subject, we substitute it in equation 2. Okay? So in other words, we take 3 in equation 2. So we can say substitute equation 3 into equation 2. You see that? All right. So now we are going to take this and replace it in here. So there we have 4 equals to A R power 4. This is equation 2. Then we have 4 equals here where there is A. You see here where there is A. We are saying that A is equals to 16 over R power 2. Meaning here where there is A, we replace 16 over R power 2. We open the bracket. You see that? What will remain there is R power 4. Like this, they are multiplying. At this time, since they are multiplying, what we are going to do here, you see here, it's more like we are dividing this R and this. We are dividing. Or to confuse you, we can put over 1 like this. Then I want to maintain this 4. So this 4 will be maintained equals, when I say 16 times R to the power 4, I'll get 16R power 4 over R squared times 1, I'll have R squared. You see this? Then now, this R I take away, and this side, since I'm dividing, and here when I take away, what I will remain with is R power 2. You see that? I'll remain with R power 2. So I'll take it this side, I'll say I'll have 4 equals to 16 R power 2. This is where I am now. I'm here. I've divided, I've remained with this. So to completely find the value of R squared, I'll just say here over 16 and this side over 16. Then I cancel. You see that? When I cancel, what to remain if is R squared equals to, I have 4 and what? I have 4 and 16. I have 4 and 16. So here I can say I'll just take it the way it is here. I have 4 over 16. Okay, first of all, I don't want to reduce it because here I have the power, I have R to the power 2. Now, how do I remove r to the power 2? You see that? So I'll introduce square root. I'll say here a square root and this side a square root. I'll cancel. Then r equals, what is the square root of 4? So the square root of 4, it is what? It is 2. Then the square root of 16, it is a 4. Therefore r equals 2 there, 1, 2 there, a 2. Okay, meaning my r is 1 over 2, which is my common ratio. So my common ratio, it is 1 over 2. Okay, so the solutions, they start from here. Okay, from that side we continue moving like this. We move up to here. Now if you look at the question, it says the first term and the common ratio. So for the common ratio we are done, which is r. Now the first term. So the first term is easy to find now. Okay, so what we can do to find the common ratio, we can use 3. You see, on equation 3 here, equation 3, a is equal to 16 over r power 2. So this is what we can do. We can just get equation 3. Okay, so this is equation 3. A is equal to 16 over r power 2. But we know that r is equal to 1 over 2. This is equation 3. This is equation 3. Okay, I'll take equation 3. So what I'll do, I'll just say A is equals to 16 over r. Okay, now r, what I want, r is power 2. You see that? So I want to change this r in point form so that it is easy for me to solve. I'll just say, I know that this 2 into 1 is 0.5. Okay, I'll put it as 0.5, then I square it so that I make things easy. So r is equals to 16 over 0.5 squared. So I'll just use a calculator. I say 0.5 then squared. 0.5 squared, I say equals, so I'll get 0.25. Okay, so here I'll get 0.25. Then my a equals to 16 divided by 0.5. So I'll just say 16 divide 0.25 equals, you see that? I'll get 64. 16 divided by 0.25, I'll get 64. So a is 64. This is my a. So my a is 64. Okay, my r is 1 over 2, which is the same as 0.5. So meaning now we have fully solved the question 1. So now we are here to the 10th term. This is easy. So to find the 10th term, we use this formula. Tn equals to a r to the power n minus 1. So what you have to know here is n. So n, they are saying the 10th, so n will be a 10. Then our a we have found to be 64. Then our r we have found to be 1 over 2. Okay, 1 over 2. So we can just replace this information that we have here. We can replace it here. So we'll say t, where there is n, I'll put 10 to present that I'm finding 10th term. Then a is 64. So a is 64 by r. So my r is what? 1 over 2. So if you want, I've been saying 1 over 2 is the same as 0.5. 0.5 is same. So me, I prefer putting it at 0.5. So 0.5. Then my n, as you can see here, is 10. So 10, then take away a 1. So from here we say now 10th term equals to 64, open the bracket, 0.5 over 10, take away 1. 10 take away 1 is a 9. Then at that point I'll just use a calculator without wasting time. Or if I want, I can say 64 will be maintained, then I deal with 0.5 to the power 9. So I'll just go on the calculator, I open the bracket, then I say 0.5 then to the power a 9. You see that? 0.5 then to the power 9. I say equals, I'll get this answer. Now I can see that the calculator is approximating the answer. So I'll just do everything at once. Okay, I'll just do everything at once. I'll just say 64, open the bracket, 0.5, close the bracket, then to the power 9. You see, I've decided to do everything at once. Then I say equals. So this is my answer, 0.125. So I've just done this on the calculator at once, and I found my 10th term to be 0.125. Okay, which is here, 0.125. This is my 10th term. Okay. Then the question continues. It says the sum to infinity. The sum to infinity. Okay, so the sum to infinity, that is 3. So sum to infinity, you use this formula. I say sum to infinity is equals to a over 1 minus r. So you have to know your a. Our a is 64. Our common ratio is 1 over 2. Okay, so we say sum to infinity equals to a. So what is my a? 64 over 1, take away my r. So they have been saying, me I prefer writing r in point form. So those who are not following are saying 1 divided by 2. You see that 1 divided by 2 is 0.5. This 1 divided by 2 is the same as 1 over 2, which is 0.5. So here I'll just put 0.5. Sum to infinity is equals to 64 over 1 minus 0.5. So 1 take away 0.5. So 1 take away 0.5, you get 0.5. So here is 0.5. Then sum to infinity equals, we just divide 64. We say 64 divide 0.5. See that? 64 divide 0.5, you get 128. So the answer, sum to infinity, is 128. We are done with the question. So this is how it's supposed to be solved. So the question was actually picked here from 2021. It was picked from 2021. From 2019. I don't know if you can see this. It was picked from 2019.